Hey there, I just wanted to talk a little bit about heat transfer. The process of kinetic energy transfer at the particulate scale is referred to as heat transfer, and the spontaneous direction of the transfer is always from a hot to a cold body. On average, molecules in the warmer body have more kinetic energy than the molecules in the cooler body. As temperature goes up, kinetic energy goes up. As kinetic energy goes down, temperature goes down. To illustrate the relationship between kinetic energy and temperature, here I have a sample cell of 72 bromine Br2 molecules at 60 degrees Celsius. I'm going to change the temperature of this system and increase it. Watch what happens to the molecules as the temperature increases. The temperature has been doubled. The temperature has been increased again. As you can see, the molecules are moving faster as the temperature increases. All of the molecules, as you can see, do not have the exact same kinetic energy. Some molecules are moving faster than others. Temperature is a measure of the average kinetic energy of all of the molecules in the system. Collisions of molecules that are in thermal contact transfer energy. Scientists describe this process as energy is transferred as heat. These green arrows are vector arrows. They represent direction and magnitude. This molecule has much higher kinetic energy than this molecule. This molecule is on the warm side. This molecule is on the cool side. Because this molecule is warmer, it has larger kinetic energy than the molecule on the cool side. When this molecule collides with this cool molecule, there's a transfer of energy from the high energy particle to the lower energy particle. The molecule that transferred some of its kinetic energy loses that kinetic energy and then slows down, cooling off. The molecule that received or absorbed the kinetic energy speeds up and its temperature increases. Kinetic energy is transferred from the faster moving molecule to the slower moving molecule. As a result of the kinetic energy transfer, the fast molecule loses kinetic energy and slows, while the slow molecule absorbs kinetic energy and speeds up. Temperature is a measure of the average kinetic energy of the particles in a sample of matter. When a thermometer is placed in a cold environment, the kinetic energy of the molecules inside of the thermometer is greater than the kinetic energy of the molecules outside of the thermometer. So the kinetic energy is transferred out of the thermometer, causing the liquid inside of the thermometer to decrease. When a thermometer is placed in a warm environment, the molecules outside of the thermometer have a greater kinetic energy than the molecules inside of the thermometer, so kinetic energy is transferred in, causing the molecules inside of the thermometer to move faster, making the liquid in the thermometer rise. molecular collisions continue. The average kinetic energy of both substances is the same at thermal equilibrium. To illustrate this, if a substance that was at if a sample of water at 5 degrees Celsius where the molecules had a low average kinetic energy was placed into warmer water at 70 degrees Celsius where those molecules had a higher average kinetic energy, over time, after a certain amount of time, thermal equilibrium will be achieved, meaning the average kinetic energy and the temperature of each sample of water will be equal. Heat is not a substance. It makes no sense to say that an object contains a certain amount of heat. Rather, heat exchange, or transfer of energy as heat, refers to the process in which energy is transferred from a hot to a cold body in thermal contact. The transfer of a given amount of thermal energy will not produce the same temperature change in equal masses of matter with differing specific heat capacities. What that means is the higher the heat capacity, the more energy is going to be needed to cause that substance to undergo a temperature change. The lower the specific heat capacity, the less energy is needed to cause that object to change temperature. Questions?